So let us understand what is principle of inclusion and exclusion. See, to understand this approach or this method of principle of inclusion exclusion, let us start the concept with the help of Venn diagram. We know very well that this specific portion represents A minus B, or we can say it represents A and not B, right? This specific portion, this red one, represents the common portion between A and B. So it represents A intersection B. And this portion, this green one, represents B minus A, or I can say B and not A, right? Now, clearly, the numbers in A minus B, or I can say the numbers in A and not B. इसका मतलब यहां पर यह है कि we wanted to find the size of A minus B. And clearly from the diagram, the size of A minus B is size A means number of elements in A reduced by numbers in A and B, right? When we subtract this intersection from A itself, then it gives numbers of A minus B or A and not B. Similarly, numbers in B minus A, or I can say numbers in B and not A. This should be numbers in B minus numbers in A intersection B, right? Now, basically, what is numbers in A union B? This A union B means at least one of A or B, which means either A or B or both. If you visualize this from the diagram, this union means the sum of all these three portions, the black portion, the red portion, and the green portion. If we add this black portion with red portion and then with green, it gives us numbers in A union B. I can also write this numbers in A and B as numbers in A plus numbers in B and not A, right? Numbers in A means this clear diagram, this one, this portion, okay? This is numbers in A. And this numbers in A, when combined with this portion, right? This portion, this gives us numbers in A union B. So this further can be written as numbers in A plus. This is numbers in B and not A, right? Now use the second result, numbers in B and not A. This is numbers in B minus numbers in A intersection B. So replace this with numbers in B minus numbers in A intersection B. So this result basically, numbers in A union B is numbers in A plus numbers in B minus numbers in A intersection B. This is basically known as principle of inclusion and exclusion. The first question which arises here, why do we call it inclusion and exclusion? Here we have added numbers in A with the numbers in B. Means A and B have been included, whereas we have excluded this intersection. That's why we name it as principle of inclusion and exclusion, right? Now, how this principle is applicable to the problems relating to set theory? Let us take, say we are given a bag consisting of 200 numbers, okay? Now, if I wish to find how many of them are divisible by 5 or 6, okay? So first we need to define the set of numbers which are divisible by 5. We need to define a set of numbers divisible by 6. So first we are assuming that the given set is S itself. So the given set is S, which consists of first 200 natural numbers, okay? Let us define A, all those X which are elements of S and divisible by 5, right? Let's call B as all those X such that X belongs to S and is divisible by 6. Now, first I need to find how many numbers are there which are divisible by 5. I hope you know very well 5, 10, 15, 20, keep on doing like this, 195, 200. All these numbers are divisible by 5. So can we count them? How can we find how many numbers are divisible by 5? One of the easiest way is, there are 200 numbers. There are 200 numbers in all. We wanted to find divisible by 5. So divide 200 by 5 and compute its greatest integer function. Compute its greatest integer function. If we write like this, so this represents greatest integer X, right? So 200 when divided by 5 gives us 40. This is numbers in A. Similarly, numbers in B. Now, how can you find numbers in B? Again, 200 divide by 6. Go for its greatest integer function. So once you divide 200 by 6, it gives 33 point something, right? So is there any integer? Is there any integer which is equal to 33 point something? Answer is no. So any integer which is less than 33 point something, that is 33. So this is the greatest integer which is less than 33 point something, right? Now, definitely there are certain numbers which are divisible by 5 as well as 6. So clearly, these two sets A and B are non-empty. I mean, there is something common between them. I mean, there are numbers which are divisible by 5 as well as 6. So if I wish to check how many numbers are divisible by 5 as well as 6, so 200 divided by, go for the LCM of 5 and 6. Means any number which is divisible by 5, which is divisible by 6, will also be divisible by their LCM, which is 30. So it gives 6 point something. So at round of result is 6. So greatest integer X would be 6. Now apply the result. Numbers in A union B. It is numbers in A plus numbers in B minus numbers in A intersection B. So what is numbers in A? This is 40. Numbers in B, 33. And then 6. Plug in the value here. Plug in these values here. This is 40, 33, and 6. What do we get? This is 73, 67. So 67 numbers are there which are divisible by 5 or 6. Right? In case we wish to find how many are divisible by 5 but not 6. How many are divisible by 5 but not 6? Then how can we? It means we wanted to find number which are divisible by 5 but not 6. Right? And the formula for this is numbers in A minus intersection. Agreed? So what is numbers in A? We already have computed. Numbers in A is 40 and intersection is 6. So 40 minus 6 means there are 34 numbers which are divisible by 5 but not 6. And in case we wish to find how many are divisible by 6 but not 5. Yes, कैसे निकालेंगे इसको? This is B and not A and should be numbers in B minus numbers in A intersection B. And I hope here we already have computed numbers in B, 33 and intersection is 6. Result is 27. Right? So this is basically how we apply this principle of inclusion and exclusion. This same law is applicable to number of problems for 3 sets, 4 sets, and even 5 sets can be extended for n number of sets, right? So let us take another example to understand this concept. Say a class of 100 students in a class of 100 students, 60 speak French and 63 speak Spanish. Every student speak at least one of these 2 languages, right? Find the number of students who speak both the languages, right? So let's see how can we do this. So clearly the question says there are 100 students, 60 are there who speak French, 63 speak Spanish, and this is the crucial line. Every student speaks at least one of these 2 languages, right? Every student speaks at least one of these 2 languages. So let us define set F as all those x, okay, that x belongs to S. Here we are assuming that S is the set of these 100 students, right? And X speaks French. Let us take S. X says that X belongs to S and X speaks Spanish. Okay. So here this 100 shows numbers in Spanish or French, means number of students who speak at least one of these two languages. The 60 are there who speak French. 63 are there who speak Spanish. Now we know that numbers in F union S is numbers in F plus numbers in S minus numbers in F intersection S. This is the same formula of principle of inclusion and exclusion, which we already have done. Okay. So union is 100. This is numbers in F is 60. What is numbers in S? 63. And what is intersection? We are to find this intersection. Okay. This is numbers in F intersection S. Now simplify this expression. When we transpose the sides, we get F intersection S as 60 plus this 63, 123 minus this 100, okay? So it gives 23, means 23 students are there who speak both the languages, right? I hope this concept is very much clear to you all. Similarly, the same law can be extended for three sets A, B, and C. This is numbers in A, union B, union C, is numbers in A plus numbers in B minus numbers in C minus numbers in A and B, numbers in B and C, numbers in A and C, plus numbers in A and B and C, right? We can derive this result even. This is the proof is very easy. So I hope you guys can try the proof of this result yourself. Again, take example that there are 1 to 500 numbers, okay? 1 to 500 numbers. Let us simplify this. 1 to 500 numbers, okay? And how many of them are divisible by, or I can say multiple of, okay? Divisible by 5 or 6 or 7. Of course, proceed in the manner as we proceeded in the previous example. X, all elements which belongs to S, okay? Let us define this S as 1, 2, 3 up to 500. Let us define A as all X such that X is an element of S. This is S, okay? X is an element of S and X is divisible by 5. Let us define B. X such that X belongs to S and X is divisible by 6. C, X such that X belongs to S and X is divisible by 7, right? Now, find numbers in A, find numbers in B, numbers in C, numbers in A and B, numbers in B and C, numbers in A and C, numbers in all three A, B, and C common elements. Okay. Numbers in A. How many numbers are there we have? We have 500 numbers. We wanted to find how many are divisible by 5. Okay. So 500 divide by 5. And then again, this bracket represents greatest integer function, right? Numbers in B, B divisible by 6. Okay. That means 500 divide by 6. Go for compute the result. This is 83 point something. So round off, it is 83. That means greatest integer of 500 over 6 would be 83. Then how many are divisible by 7? 71 point something. So greatest integer would be 71. A and B means those numbers which are divisible by 5 as well as 6. So those also are divisible by LCM of 5 and 6. The LCM of 5 and 6 is 30. So this gives 16 point something. So this gives 16, right? Okay. This is B and C. B and C means LCM of 6 and 7. And LCM of 6 and 7 is 42. So I guess this gives 11, right? Then A and C, 500 divide by LCM of 5 and 7. LCM of 5 and 7 is 35. Compute. So 14 point something. So greatest integer is 14. And then A and B and C means LCM of, yes, LCM of what? 5, 6, and 7. Agreed? So this is 500 over LCM of 5, 6, 7. This is 30. And 30 and 7, 210. So this gives 2, right? The whatsoever the values of these A and B and C and numbers in A intersection B, B intersection C, A intersection C are to be plugged in the value formula. The formula we have is numbers in A plus numbers in B plus numbers in C, numbers in A and B, B and C, C and A, plus A and B and C. So substitute these values here. This is 100. This is 83, 71, 16, 11, 14. Calculate the result, you will get the answer. Fine. So this is some basic conceptual part relating to this principle of inclusion and exclusion. Thank you.